Now let's do number 8. In number 8, we have a circuit that looks like this. Resistor, diode, resistor, diode. 9 volts, 220, E1, E2 is shown here. Resistors. Okay, so there's my circuit, 2 resistors, 2 diodes. We're asked to find the voltages and the currents in the circuit. So the first thing I do is determine the polarities everywhere in the circuit. So plus minus, plus minus, plus minus, plus minus, and plus minus. You follow? We start out with the supply and work around in the circuit. And so that tells me are D1 and D2 forward biased or reverse biased? Forward biased. R2 and R1 are 2 resistors in a series circuit. I can talk about an equivalence resistor, which is going to be in a series. Do the resistors add up, or do they do something else for the equivalent resistance? They would add. So our equivalent would be R1 plus R2, which is 550. So you could replace those 2 resistors with 1 resistor, 550, and that will help us find the current in the circuit. So VD1, 0.7, VD2, 0.7. Everybody see that? As long as the supply voltage is higher than the 0.7 and 0.7, then we're okay. That's what we will read. In the lab, when you build a circuit like this, you may not read exactly 0.7. It may be 0.65, it may be 0.68, but we use 0.7 as a rule of thumb. In electronics, in electricity, we're going to use a lot of rules of thumb. A rule of thumb is something that is, it helps us quickly understand the circuit. So these are quick tips. They're like quick tips, rules of thumb. Okay, VD1, VD2 are 0.7 and 0.7. Let's find I first. I, V over R. So that would be the current in this circuit, series circuit. V would be 9 minus 0.7 plus 0.7. Okay? The total voltage would be 9 minus 0.7 plus 0.7 divided by R1 plus R2. So in the circuit, the current is 9 minus 1.4, which is how much? 7.6 over 550. $13.8 milliamps. So that's the current flowing in this circuit. 13.8 milliamps.
It's only funny when I don't do it.
Okay. So now that I know that the current in the circuit is 13.8 milliamps, I can find the voltages at R1 and R2, because that is 13.8 times 220 for R2, 13.8 times 330 for R1. voltage is I times R. So voltage at R2, I times R2. 13.8 times 220. How much?
It's more. I just want to read it.
Milli times ohms is millivolts, right? So you can convert it to volts. 3.04 volts. If you take that milliamps and multiply by ohms, you would get millivolts. Then you convert it to volts. VR1, I times R1. Do you see how you're using the principles that you learned in electricity 1 over and over and over? Series circuits, parallel circuits, Ohm's law, all those are used in our study of electronics. 13.8 times 330. 4.6 volts. So that's finding the resistance, the current. Let's see if all my voltages add up to 5. So test. Kirchhoff's voltage law. Let's add up the voltage at 220, which is 3.04. Voltage at D1, 0.7. These are the drops. Voltage at R1, 4.6. And the voltage at D2, 0.7. What do we get? 5.0. 9 volts. Okay, all the voltage drops should equal to the voltage rise, which is the supply voltage. Make sense? So that's number 8. We'll come back to number 9. Let's do number 10 first. Let's do number 10.
What? What?
We're not getting into this. We're not getting into this.
Actually,
Especially not with the camera tracking my.
Number 10 shows 4 diodes with a 9 volt supply.
I already said we're not getting into this. We're not getting into this. It's like
One is pointing down,
It's like a genius.
the other is pointing up.
That's why. That's why the whole thing.
One is pointing up,
Wait a minute. What do you mean?
the other one is pointing down. And then in the middle, I've got a resistor. Okay. Supply is 9 volts. D1, D4, D2, D3. R1, 1K. So, right away, I start putting the pluses and minuses on the circuit. So here's my supply. It's going to cause current to flow. So as far as polarity is concerned, here's plus minus. So it would be plus here, minus, plus here, minus. You see that? On the other side, same idea. Plus, minus, plus, minus. That will tell me if the diodes are, which diode is forward biased and which one is reverse biased. So, let's do D1. Is D1 forward bias or reverse bias? Forward. D2. Reverse. D3. Forward. D4. Reverse. Okay? D1 is forward, anode is positive. D2 reverse, anode is negative. D3 forward, anode is positive. D4 reverse, anode is negative. Yeah, we'll come to that when we do the calculation. So, currents. So this one is now going to be closed. This guy is going to be open. This one is open.
The right side only went down.
And this one is closed. So, current's going to flow through this closed switch, cannot flow this way, so it's going to flow through R1, down D3, and back. Okay? So the current is going to flow this way, which means that the polarity will be plus minus. So the current is going to flow through the diodes, which act like closed switches, which are forward biased. So therefore, I, at the resistor, V over R, what about the voltage? I've got a circuit with one diode, resistor, another diode, and back. So is it 9 minus voltage at D1 minus voltage at D3 divided by 1K? Everybody see that? 9 minus 1.4 divided by 1K? 7.6 milliamps.
I'm gonna bring it up if he doesn't do it.
Okay.
I know, you're single and ready to mingle. If you're single and ready to mingle, giving me the come from me, and then kind of look at me.
Let's do number 11.
But you're left.
Yes.
The current goal from the split up to D2 flash down.
D2 is reverse bias, so it's open switch. So it cannot flow. Current will go from the positive side, it has to come back to the negative side. So if you do this, it cannot flow this way, it's going open switch. First, the voltage determines the behavior of the diodes. And then current will flow through the diodes that are forward biased and diodes that are reverse biased.
So the current is actually flowing over
This way, it can't go down this way, so it goes through here. It's like a mouse trap, mouse maze, and back.
Private?
It's very similar to the 4 diodes we will use to build the power supply circuit.